students, welcome back. Today I will be teaching you on current electricity. Electricity is all around us, powering technology like our cell phones, computers, lights, soldering irons and air conditioners. It is tough to escape it in our modern world. Even when you try to escape electricity, it's still at work throughout the nature, from the lightning in a thunderstorm to the synapses inside our body. So what is exactly electricity? This is very complicated question. Electricity is a natural phenomenon that occurs throughout the nature and may take different forms. In this tutorial, we will focus on current electricity, the stuff that powers our electronic gadgets. Let's see what is current. Current is actually the flow of charged particles. Current is defined as the rate of flow of charge. In other words, current flowing in a conductor is the amount of charge flowing per second through it. This figure shows one section of a conductor. So if Q charge flows through the cross section of the conductor in time t, then the current I flowing through it is given by current I is equal to charge Q per time. Now what is the unit of current? The SI unit of charge is coulomb, and therefore current is measured in coulomb per second, which has been given the name ampere. The symbol is A. Current is measured using a device known as ammeter, which is always connected in series with the circuit. Ampere is defined as the amount of current which flows when 1 coulomb of charge passes in 1 second. There are smaller units of current, which is 1 milliampere, that is equal to 10 to the power minus 3 ampere, and one is microampere, which is 10 to the power minus 6 ampere. Now flow of current. Let's be reminded of some about chemistry. You remember that the atom contains a say atomic number, mass number, neutrons, protons and electrons, right? And we know that always the number of electrons in an atom is equal to the number of protons present in the same atom. So here and the inside the nucleus we have proton and neutron, and in the orbits we have the electrons. The outermost orbit contains an electron which is known as the valence electrons, and these valence electrons are mostly responsible for flow of current. In this atom we can see there is one valence electron at the outermost cell or one free electron. Let's see. In metals, the moving charges are the free electrons, which constitutes the current, while in electrolytes and ionized gases, positively charged cations and anions are the moving charges which constitute the current. Now suppose in the diagram below, we can see a part of a conductor. It consists of several atoms, and this figure shows the electron at the outermost orbit, or the valence electron or the free electrons. So if n electrons pass through the cross section of conductor in time t, then the total charge passed through the conductor is given as number of electrons into the charge on each electron. And what is current? Current is charge by time. So Ne by T. And charge on one electron is this much. So therefore 1 coulomb charge is carried by 1 divided by 1.6 into 10 to the power minus 19, which becomes 6.25 into 10 to the power 18. So the number of electrons which flow when 1 ampere current flows, the number of electrons passed in 1 second is 6.25 into 10 to the power minus 10 to the power 18. What is potential? I have attached four diagrams here. Let's see the first one. Here you can see there is a water level in vessel A at a higher level, and in vessel B there is water level at a lower level. But the vessel B is thicker and the vessel A is thinner one. The direction of water flow will be from vessel A to vessel B. Why? Because the direction of water flow depends upon the level of water. Since the level of water or the height of water level is higher in A than B, so water flows from higher level to the lower level. Similarly, here the stone is dropped freely from a place high to the ground. So here what we can see, it has been going from higher potential energy to lower potential energy. Similarly, this object shows that there are two vessels, which one is on higher temperature and another one is on lower temperature. When they are connected, heat flows from higher temperature to lower temperature. Always we can see from these three figures that always the direction of flow is from higher level to lower level of energy, higher potential energy to lower potential energy, higher temperature to lower temperature. Similarly, here all the positive charge are said to be at higher potential and the negative charge is said to be at lower potential. So the direction of flow is always from higher to potential to lower potential energy. Each object has a tendency to move from a position where its potential energy is high to a position where its potential energy is minimum, as we have seen in this figure and all these figures. In a similar manner, if two charged bodies are joined together by a metallic wire, the charge in them moves in a direction determined by the quantity called electric potential. Let's see this figure. This A has excess of electrons and the body B has deficit of electrons. We have already studied that wherever there is positive charge or deficit of electrons, that is at higher potential, and this one is at lower potential since it contains excess of electrons. Electrons will flow from this part to here where there is deficit of electrons. Here there is excess of electrons and this one is deficit of electrons. So flow of electrons will be like this, but flow of current will be always from higher potential to lower potential. So electric current will flow from B to A. Potential is the electric state of a conductor which determines the direction of flow of charge when two conductors are either kept in contact or they are joined by a metallic wire. Now, what is a potential difference? We all know that electrostatic force law. What does it say? Whenever two like charges come together, they repel, and when unlike charges come together, they attract. If suppose two positive charges we have to bring together, then what happens? Positive charge will repel each other. Similarly here, let's see this diagram. Here A is a positive charge and B is also a positive charge. If we try to bring them closer, what will it happen? They will try to repel each other. But we have to, if we want B to move towards A, what we will do? We will put a force to it and move some distance. Force into displacement is work. So what we do here, that we do some work to bring the body B towards A. The potential difference between 2 points is equal to the work done in moving a unit positive charge from one point to another. It is a scalar quantity. If W joule of work is done in moving a test charge Q coulomb from a point A to a point B, then the potential difference between the 2 points A and B is VA minus VB is equal to W by Q. The potential difference between 2 points in an electric circuit is measured by a voltmeter, since potential difference is a voltage. So it is measured by voltmeter, which is connected across those points in parallel with the circuit. Whereas current was connected in series. For measurement of current, we used ammeter, which is connected in series with the circuit. Here, for measurement of voltage, we have to connect it in parallel with the circuit. Now, what is the unit of potential difference? As I have already said that it is a voltage difference, so unit is in volt. Potential difference is also expressed in volt. The potential difference between 2 points is said to be 1 volt if the work done in moving 1 coulomb charge from one point to another is 1 joule. So if we want this one to be 1, so what we'll put in numerator and denominator, we need 1. So 1 joule of work, 1 coulomb of work will give a potential difference of 1 volt. This was discovered by scientist Alessandro Volta. Now let's see, what is a resistance? Resistance is the obstruction offered to the flow of current by the conductor or the wire is called resistance. As we can see, the current is flowing in the blue color shows the current direction in a conductor. But the obstruction which has been present in black arrows shows the obstruction. Obstruction offered to the flow of current is resistance. And how can we offer resistance to the flow of current? By putting a resistor. This one shows a resistor which we can put to obstruct the flow of current. The resistance symbol is in the circuit. It can be represented in this symbol or in this symbol. Factors affecting the resistance of a conductor. There are 4 factors which affect the resistance of conductor, mainly nature of conductor. Different substances have different concentration of free electron. Some are good conductors such as silver, copper, lead, aluminum. Some offer high resistance and are called insulators such as rubber, glass, wood. Then length of conductor. In a long conductor, the collisions will be more. So if the length is more, resistance will be more. It is directly proportional. Thickness of conductor. If it is a thick conductor, then electrons get larger area of cross section to flow compared to a thin conductor. Therefore, a thick conductor offer less resistance. So R is inversely proportional to the thickness of conductor. So if more thickness means less resistance. If more resistance means less thickness. Now temperature of conductor. With the increase in temperature of a conductor, the random motion of electron increases. Hence the resistance of a conductor increases with increase in temperature. Now Ohm's law. Ohm's law, Ohm is a scientist who discovered a certain formula which is known as V is equal to IR. Voltage is equal to current, the product of current and resistance. According to Ohm's law, the current flowing in a conductor is directly proportional to the voltage difference across its ends, provided the physical condition and temperature remains constant. This is the limitation of Ohm's law, which Ohm's law is obeyed only when the temperature of the conductor remains constant. Ohm's law gives us 3 main formulas. One is this one, V is equal to IR, and another one is I is equal to V by R is equal to V by I. Now what is unit of resistance and conductance? From the relation V is equal to IR or Ohm's law, we can derive the unit of R becomes V by I. So V is measured in voltage, is measured in volts. Unit of I is in ampere. So volt by ampere, right? Volt by ampere, which is named after the scientist Ohm as Ohm. So volt by ampere is named as ohm, and it is denoted by the symbol omega. There are higher units of resistance. One is kilo ohm, that is 10 to the power 3 ohm, and mega ohm, 10 to the power 6 ohm. And then what is conductance? Conductance is a reciprocal of resistance, 1 by R. Its unit is Siemens, and the symbol is given here, ohm inverse. Ohmic, non-ohmic resistors and superconductors. The conductors which obey Ohm's law are called ohmic resistor or linear resistor. Silver, aluminium, copper, iron are those types of conductor. Then which do not obey Ohm's law are called non-ohmic resistors or non-linear resistors. LED, solar cell, junction diode, transistor, these are all non-linear resistors. What is a superconductor? Superconductor is a substance which shows that the resistance of this substance decreases tremendously with decrease in temperature and becomes absolutely zero. So these are superconductors. Mercury, lead, niobium are superconductors. Now specific resistance or resistivity. From experiments, by studying some graphs and experimentally proved that R is equal to rho L by pi R square, or R is equal to rho L by A. Resistivity is the rho. Rho is equal to, so experimentally observed what I told, R is equal to rho L by pi R square. So what is rho? Rho becomes R into A. Pi R square is A, area of cross section, rho A by RA by L. So resistivity becomes RA by L. Unit of resistivity from this above formula, what we can write? Unit of R into unit of A into unit of L. That comes to ohm into meter. Thus the unit of resistivity is ohm meter. Now factors affecting the resistivity. What are the factors which mainly affects resistivity? One is the material of the substance, and second one is the temperature of the substance. Resistivity increases with increase in temperature for metals, but it decreases with increase in temperature for semiconductors. For some alloys, it remains practically constant with change in temperature. So material of the substance, it is very low for metals. Resistivity is low for metals, low for semiconductors, but high for insulators. Now what is conductivity? We have already studied what is conductance. It is reciprocal of resistance. Similarly, what is conductivity? It is reciprocal of resistivity. So sigma, it is denoted by sigma, and that is 1 by resistivity, that is L by Ra. SI unit is Siemens per meter inverse. 1 by ohm into meter, that is ohm inverse or meter inverse, or Siemens into meter inverse. Why? Ohm inverse is known as Siemens. Now choice of material of a wire. So whenever we need a particular function, we need to choose a special material or a special wire for it. So the wire used for electrical connections and for power transmission should possess negligible resistance. So they are made of materials like copper, aluminium, whose resistivity is very small. Also they are made thick, so resistance becomes low. Silver has all these qualities, but it cannot be used because of high cost. Now suppose we need a resistor. I have shown you a picture of resistor earlier. These resistors are made of alloys like tungsten and manganese for low resistivity, and also that resistivity decreases with temperature. A fuse wire is made of alloy of lead and tin because of low melting point and more resistivity to allow safe limit of current. So tungsten wire is used in filament of bulb because of high melting point and high resistivity. Nichrome wire is used in heaters, toasters, any cooking hob because of high resistivity, and also resistivity increases with temperature. So according to the purpose we need to choose the material of a wire. Thank you for watching my video. Please subscribe to my channel. I will be dealing with series resistance and parallel resistance in the next video. Thank you.